Hello everyone. In this session, we are going to study regarding the types of foundations. Now, foundations are classified according to the depth as a shallow foundations and deep foundations. When foundation is placed immediately below the lowest part of the structure, it is termed as shallow foundation. In this foundation, depth is less than or equal to its width, and in a deep foundation, when deep depth is more than its width or 5 meter, the foundation is termed as deep foundation. This is a flow diagram of various types of foundation. You can see foundations are classified into two categories: shallow foundation and deep foundation. Shallow foundation is further classified into as a wall footing, or which is also called as a strip foundation, that is subdivided into simple wall footing, stepped footing. Then it is also categorized as column footing. It is a isolated type of footing, in that a special foundation is there which is called as a isolated footing itself, combined footing, continuous footing, cantilever or strap footing. Then it is also divided into shallow foundations, inverted arch foundation, raft or mat foundation, grillage foundation. Then deep foundations are divided into file foundation, pier foundation, caissons or caisson foundation. In that it is also divided into box caissons, wells or open caissons, and pneumatic caissons. Shallow foundations. Now we'll see regarding the wall footing, column footing, inverted arch footing, raft or mat footing or mat foundation, grillage footing. Now wall footing, wall itself transmit load over large area below the foundation. Classification of wall footing, it is a spread footing and stepped footing. Now this is a very simple type of foundation. You can see here a wall is resting on a plain cement concrete base or bed, you can say. It is, and you can see if this is the wall, then this width of this strip or this concrete bed, it is more than the wall. So this distance which is more than the wall, you can see on both the side. So this is distance left which is called as a offset. It is called as a offset. Also remember the symbols of this. This symbol stands for the brick wall, two continuous lines space, two continuous which are drawn at the 45-degree, and this is the symbol for concrete. Also you can see this is a ground level. Spread footing, width of footing is slightly more than a wall above, generally used for garden wall and temporary structures. Wall footing, again it is further divided into stepped footing. Offsets are provided on either side of wall, generally used for ordinary building. You can see the steps are provided here, okay, which are offset itself. So the load which is coming on the foundation, it is distributed on the more area. That is the main function of the foundation. Okay, so the symbols are same again. GL stands for the ground level here. Then column footing, it is similar to the wall footing. Column transmits load of superstructure to the subsoil. Now there are various types of column footing: isolated footing, combined footing, continuous footing, cantilever or strap footing. In isolated footing, you can see a RCC column which is transmitting the load to below on a foundation. Okay, so this is a trapezoid shape is given. You can see this particular to economize that particular, and here the reinforcement is placed here vertical in the column and also in the at the bed. This type of foundation provide separate to you every column symmetrically. It is used for the framed structure. Combined footing, two columns are closely spaced. In that case, instead of isolated uh, footing, we provide combined footing, but resultant pass through center of gravity of footing to avoid load concentration. Now you can see here uh, this W1 and W2, which is load coming on the columns, and this is the base provided. Instead of a single column, we are providing the two columns which are closely spaced. Now here, as the load on the W2 it is more than, so it is a trapezoid type footing is provided. If the W1 and W2 equal, then this base can be provided as a rectangular. Okay, so combined footing, that may be a trapezoidal combined footing, or that may be a rectangular combined footing. Okay, you can see here this is a rectangular combined footing when W1 and W2 are same, so you can provide the same area for each column, but when the load coming on one of the column is more, on that side the area we are providing more area. It is a trapezoidal combined footing. Then continuous footing, when many columns in row, in that case instead of isolated footing, provide continuous footing. So if the many columns are there, so every time separate footing is not advisable there. So in that case a single base is provided for that column. So that if it is more than two columns, then we are terming this as a continuous footing. Okay, so it is a continuous base is there for the these four columns in this case. Cantilever or strap footing. In case of exterior columns, exterior mm, case, you can see column is located very close to the plot boundary, so isolated footing may go outside. In such cases, exterior column connected to internal using strong beam. Now, if suppose on this side here, this is the column which is on the boundary. This is the exterior column. So, if you want to provide you can see equal offset on the both the side, but on this side our boundary is not present there. So here, so this offset may go outside of this, right? So that is not permitted because this is the neighbor's boundary and we cannot cross that. So instead of that, this cantilever strip is provided, and the load which is coming on this exterior column, which is transferred to the internal column, and this is also a supportive base is there. So so that we are avoiding here to entry of the offset of this column into the neighbor's boundary. Then raft or mat foundation, when bearing capacity of soil is low, in that case other column footings are ineffective due to unequal settlement. We use raft footing. Entire area below building is excavated and RCC slab is laid. Now suppose this particular area, total area of that building, it is having the different bearing capacity as the different places, and if you are using the isolated footing at every point, so it is quite possible that the settlement take place, and that is a very detrimental to the structure. So instead of that, this total area, this total area is excavated. Total area is excavated, and a RCC at the bottom. You can see this at the bottom. RCC slab is placed. Now there are many configuration of this RCC slab as well, right? That depends upon how you are designing the slab. So the reinforcement is also there. So you can see these are the columns which are present, okay, and these are the cross beams. These are the cross beams. So sometimes the beams which are carrying the major load, those are called as a primary beams, and those are only used for the connecting the other columns. Those are called as the secondary beams. Okay, so please remember all this terminology. Grillage foundation: when column carries heavy load which transfers to the soil of low bearing capacity, this type of foundation is provided for workshops, factories, theaters, malls, etc. So you can see, especially in the steel structure, this is the load which is carried by this column, and which is resting on a this plate, base plate, right? Now, what is done initially? This total area for that particular column is that excavated. At the bottom, this um, lower tier, it is called the lower steel joist. It is provided here. So you can see these are connected by means of by using these bolt fixtures. These are used for the bolt fixtures. Perpendicular to this, so you can see these are called as the upper tires. These are also steel joists are there. On that, this base plate is resting, and on the base plate this column is kept, and which is connected with this particular cleats, you can say. Okay, so it is either riveted or welded there, and so while doing this, step by step, this area is filled with the concrete, so that this it can take the maximum load. Inverted arch foundation: in this foundation, arch built between the two walls, load transfer over large area using arch action, reduce the depth of foundation, and provide heavy outward thrust. But nowadays it is not used. Uh, it is obsolete now because other foundations are available. So you can see in normal arch action you can understand the same thing is there. It is an inverted arch. So this column is giving the pressure on these arches, right? And because of the arch action, it can sustain the load. So more skill is required also to construct this, but nowadays it is not used in the practice. Deep foundations: if depth of foundation is more than its width or 5 meter, it's called as a deep foundation. This type of foundation is used for heavy structure such as bridges or multi-storied buildings, and soil below foundation is not suitable to bear the load. Types are pile foundation, whale foundation, and pier foundation. Pile foundation: it is thin long column which is used to transfer the load to the deep soil or up to hard strata. It is adopted when column foundations are unsuitable. Generally, this foundation is used in the black cotton soil. Okay, so as we know that the black cotton soil is having the property that when it comes in contact with the water, its volume increases or it swells. But when the moisture goes out, especially in the summer, when the soil dries, the volume uh, decreases or it shrinks, and because of this swelling and shrinkage action, the cracks are developed in the soil, especially in the summer, and this property of soil is very dangerous. So most suitable foundation is a pile foundation, because pile is generally rested on a hard stratum. So this property of soil that is neglected, because we are directly connected with the hard stratum. The classification of pile. Pile mainly classified as a functional various categories. In the functional classification, it is a bearing pile, friction pile. Okay, the pile which rests on a hard stratum, it is called as a bearing pile or a sorry, end bearing pile. Friction pile, when the hard stratum it is very at a great depth, so we cannot go for that particular resting the end of the pile on that stratum. Instead of that, friction between the surface of the soil and the surface of the pile, that will taking the load which is coming from the superstructure. So that is called as a friction pile. As per the material used, concrete pile, wooden pile, RCC pile, steel pile, composite pile, these are used as per the situation. These use are as per the requirement. Now, if you take the examples of this, one is the bearing pile, or it is called as end bearing pile, where you can see the piles are resting on a hard stratum. So this is a soft area, this is a soft soil, so where we cannot keep our end of the pile here in between. So all the piles are resting on this, and this is called as a concrete cap, and the load is taken by the wall there. Okay, friction pile, you can see when the hard stratum is at a great depth, so these are the friction piles. So the contact area between these piles, okay, the friction between this contact area of soil and pile, that is going to take the load from the superstructure. Okay, so these are called as the friction piles. So sometimes to give support to this, sometimes some bulbs are also used here. Bulbs are also used here, and those are called as a under rimmed pile. Under rimmed piles. So remember that as well. Then next is a well foundation. These are generally used for the bridge piers. Okay, you can see here. Yeah, this is the bridge pier is resting, but at bottom you can see uh, this concrete plug is placed. These are called as a curb or cutting edges there. This is a RCC well is there, okay, which is placed on this bottom plug. Okay, so when the bridge for the bridge construction, it is excavated, a temporary dam is prepared, which is called as a coffer dam, and the water is diverted from that, and at that position, this bottom plug is placed. It is a heavy mass concrete is there. Then this RCC uh, well is placed on that. Okay, and this filling is carried out. Material is filled in this, and again a concrete top plug is placed here to avoid the entry of water in that, and also a well cap is placed. Okay, so that this total area is sealed there, and above that the our column of the bridge or the spear of the bridge is constructed on this. So all this structure is there which is taking care of the bridge pier. The next is there pier foundation. It is massive column or of large diameter 0.75 to 3 meter. Its depth is up to 40 meter, and when heavy construction in soft and sandy soil, this foundation is used. So it is as good as a column itself, remember, but it is having the large diameter 0.75 to 3 meter, and depth is up to 40 meter. So please remember that what is a pier foundation. Then a special type of foundation is also there, which is called as a machine foundation. The design of foundations of turbines, motors, generators, compressors, and other machines having a rhythmic applications of unbalanced force requires special knowledge of theory of harmonic vibrations. Uh, Inertial forces of rotating elements of machines contribute additional dynamic loads besides static loads. The dynamic forces are transmitted to the foundation supporting the machine when the operating frequency of the machine trends to be equal to the natural frequency of the foundation, resonance occur. So here when you are designing the foundation for a machinery or the equipment, where all the forces, dynamic forces, will have to consider when you are designing the foundation, especially you can say the impact forces, oscillations of the machine, then you can see the reciprocating forces are also there. So all these forces will have to consider in the design of the machine foundation. So classification of the machine foundation, there are four types. Block type of foundation, it consists of a pedestal of a concrete on which machine rests. This is provided for machines to producing periodical and the impulsive forces. Wall type of foundations, a pair of walls supporting to the platform for machine is provided. Box type of foundations, it consists of hollow concrete block supporting the machine. And in the frame type of foundation, vertical columns support a horizontal network of frame. Machines working at high speeds and the rotating machines are mounted on the frame type of foundations. So you can see these are the various types of machine foundation. You can see massive block is provided. Okay, these are the showing the this machine foundation. A box is provided in case of a box type foundation. Then in the wall type of foundation, as we have seen, the walls are provided, and in the frame type of foundation, a frame is used to carry the all types of loads. So this is a special type of foundation that is used especially in the workshop, factories, or where the machines where the it is possible to come arrive the various vibratory load as well, right? So friends, here we are completing all types of foundations. So in the coming lectures, we are again discussing the regarding the various parts which are associated with the construction. So attend all the sessions. Thank you very much.